Option chains, or more generally a list of derivatives on the underlying index, stock, or future, can be queried from the API. This can be done either with the function recContractDetails or the function recSecDefOptParams. Each method has advantages in different situations. First, we'll discuss recContractDetails. This function is invoked with an object of the contract class as an argument, and in response, full details for matching contracts in the Interactive Brokers database is returned. It is the only function in the API which can be used within completely defined contract objects. From a single recContractDetails request, if there is one matching contract, full details about that contract will be returned, such as, for instance, the primary exchange, instrument name, valid order types, and trading hours. If there are multiple matching contracts, for instance, different options which have the same underlying symbol and expiry date but different strike prices, there will be separate individual callbacks to contract details with details for each option contract. And finally, if there are no matching contracts, just the error 200, no security definition has been found will be returned. It is important to note that some instruments in the Interactive Brokers database may have thousands of derivatives. In this case, it would not be possible to request a complete chain at once with details of all the derivatives on that underlying. Instead, it's necessary to narrow down the requested option chain as much as possible. For that reason, it is also best to create a local cache with return contract details rather than to make the same request repeatedly. Next, we will discuss an example of recContractDetails and how it can be used to query an option chain for Apple options expiring in June 2020. If you've watched the previous lessons, most of this code will look familiar. It's a very simple sample program which just has the minimum parts necessary to invoke the function recContractDetails to receive the results, print them to the screen. As always, first we have a new class which derives from eWrapper and eClient so that it can inherit all the necessary functionality. This is the PyCharm IDE, and on the left we've made the Python client as part of the Python path so we can find the IB API source module. In the main function, after we create an instance of the new object TestApp, which derives from eClient and eWrapper, we next call connect. After connect, we then enter the run loop with a timer to stop the loop after 4 seconds. In the run loop, the first thing that will happen after connection is we will receive the next valid ID. Start is where we can begin actually sending messages to TWS, and that shouldn't happen before the next valid ID is received. So to receive this option chain, what we will do is to have a contract object which is incompletely defined. That is, it doesn't refer to a unique object in IB's database. You'll see that we have different fields defined, such as AAPL as the underlying symbol for the option. Security type would be OPT for option. Exchange is smart, so that would mean any exchange on which this particular option can trade. Currency is USD. And then last trade date or contract month is 2020-06 for June 2020. So the fields we haven't defined here would be the strike, the right, and so that's why it's incompletely defined. So next, if we call recContractDetails with this contract object, we'll get back all those different options in IB's database which match these parameters. So that would be each option expiring in June 2020, but with a different strike and right. TWS will receive this request. It'll send us back those individual matching contracts, with each having individual callback to the function contract_details. And here we'll just print the data to the screen. In a real program, of course, you'd probably do something differently. And then finally, after all results have been returned, this will be indicated by TWS by the contract_details end function callback. So we already have TWS up and running, listing on socket port 7497, so we can just run this program and then view the results. So you can see it's quite a large option chain, even though we just defined most of the fields. At the very beginning, we'll connect, and we receive the usual callbacks, let us know the market data farm is okay. And then afterwards, we can see the results. So each of these corresponds to a single callback to the function contract_details, indicating a single option in the chain. So for instance, this would be the Apple option expiring in June 2020 with a strike price of 100, and it's a call. The next one is also an Apple option expiring in June 2020 with a strike price now of 105 and also a call. And then so on for all the different options in the chain. If you were to, say, try to get all the options on all months with all strikes for Apple, this wouldn't be the best way to do it because there would be too much data returned and the data can be throttled. So that leads us to the next part, which is a discussion of the function recSecDefOptParams. When this function is invoked, a list of all possible strikes and the list of all possible expiries is returned. RecContractDetails can then be used to query particular individual combinations of strike and expiry. So this function, recSecDefOptParams, is a bit different in that rather than giving us detailed information about each individual option, it just provides a list of strikes and a list of expiries. And then we can use the function recContractDetails if necessary to receive particular information about one individual option. So we have a short script here, which is similar to our previous script, just to show the results. So this is a short sample program to demonstrate the function recsec.defaultparams and the expected results. It's very similar to the previous program. The only difference is that we have a different function we invoke this time. So if we go to our start function, we can find now we're invoking recsec.defaultparams. And the parameters which this function takes are first just an ID to label this request in case you have multiple requests going on at the same time. The ticker symbol for the underlying, so we're looking for derivatives on AAPL stock. The third field is only used for futures options, in which case it would be the exchange. Then next we have the security type of the underlying, which would be STK for stock. And finally, the contract ID of the underlying. And for Apple stock on NASDAQ, that would be 265598. So the contract ID is an IB unique identifier, which is different for every contract in IB's database. It can be looked up either in TWS by right-clicking on an instrument and going to Financial Instrument Info and then Details, or it can be looked up using the function recContractDetails, which will return the contract ID among the other details. The results are then passed back to the function security definition option parameter, and that will just give us the rec ID, which would be 1 in this case, the exchange, which is all the possible exchanges on which the derivatives trade, the underlying contract ID, other information such as the trading class, the expirations, which is just a list of dates on which derivatives expire, and the different strikes would just be the different strike prices of the derivatives. So now we'll just run that program to take a look at the results. Okay, so this is a list of all strikes and expiries on the different exchanges for derivatives on AAPL stock. So for one particular callback to security definition option parameter, you can see we have an exchange where options trade, which would be CBOE. The underlying contract ID, as we mentioned, for Apple is 265598. The trading class here, though it's not usually used as much for stock options, but it would be AAPL. And then we have a list of the different expirations. For instance, the next one would be 12/21 or December 21st, 2018, going all the way out to June 21st, 2019. And then we have the different strikes, beginning all the way from 2.5 up to 440. So it's important to keep in mind, this is just a list of expiries and list of strikes. And every particular combination is not necessarily valid. So they would need to be queried individually using the function recContractDetails. So if you're, say, trying to build a graphical user interface for your program, how you could do that, you can use recsec.defaultparams first to get this list of strikes and expiries, and then use the function recContractDetails to ping individually different combinations of strike and expiry around the current market price to populate in the user interface. So that's our example of using the function recsec.defaultparams. Next, we'll discuss how to receive portfolio data in the API. So a common task of an API program is to receive real-time information about the current portfolio which the user has access to. It's important to note first that historical portfolio information is not available by design since TWS is a trading application, and it's also not available then to the API. There are several different functions in API which can be used to subscribe to position updates. Each follow the same subscribe and publish model, where an initial subscription request is made, then TWS will send back a complete list of all positions matching the query, and afterwards continue to send back updates to the list as they occur in real time until the subscription is canceled. So the first function is recAccountUpdates. This function causes both position and account information to be returned for a specified account. It can only be used with a single account at a time. That means it's most commonly used in single account structures, and if you have a multiple account structure, such as an advisor account or a linked account, more commonly a different function would be used. A second function which can be used to query position information is just called recPositions. This is subscribed to position updates for up to 50 sub-accounts simultaneously. So if you have an advisor account with multiple sub-accounts or an introducing broker account with multiple sub-accounts, this would be the function commonly used. It's important to keep in mind that if there's a very large number of sub-accounts, you'd likely need to use a different function, such as the one recPositions multi subscribes to position updates in a single sub-account and or model portfolio. It's commonly used in the case where there are many sub-accounts and the function recPositions can't be used to receive position updates for all of them, or in case you're interested in the positions in a particular model portfolio, which are sometimes enabled on request in financial advisor accounts or introducing broker accounts. It's important to keep in mind that these functions will only return information about current positions in the account by design. They can't return information about historical positions. If you're interested in receiving, say, information about positions in your account from yesterday or last week, this can be obtained through flex queries or statements in account management. It's even possible to obtain programmatic access to Flex queries using the Flex web service. Another common point of confusion is with cash balances. So virtual cash positions, which don't represent real cash balances, but are only bookmarks used by Forex traders to track trades, are returned with position information, and are represented by a Forex pair, for instance, EUR.USD. However, real cash balances are returned with the account information, discussed next, and always listed as a single currency and not as a pair. So for instance, you might see a cash balance of 20,000 USD, but if you see a pair such as EUR.USD, that doesn't represent a real cash balance, but actually a virtual position. Account information, such as the net liquidity in the account, cash balances in different currencies, and the required margin amounts, are returned after calling several different functions. First function, which is commonly used, which we discussed earlier, is rec account updates. This returns information about both positions and account data in a single account at a time. Or in the case of financial advisor accounts, you can get aggregated data from all sub-accounts. However, it can't be used to subscribe to updates from, say, multiple sub-accounts simultaneously. The second function is rec account summary, which is more commonly used in different account structures to subscribe to account updates from multiple accounts at once. And then finally, there's also the function rec account summary multi, which is used to subscribe to account updates from single sub-accounts at a time in the case where there are more than 50 sub-accounts, and it's also used with portfolio models. When requesting account data from the API, a complete list of all types of data or account keys is initially returned, and then updates are sent either if there is a trade or if the value has changed within the 3-minute period. This corresponds to the same update pattern which you would expect in the TWS account window. Here is a short sample program on using the function rec account updates. You'll notice it looks very similar to the previous programs. The only difference is the function we call here in the start function will be rec account updates, and then the callback functions we've overridden to handle return data are update portfolio, update account value, update account time, and account download end. So after we invoke rec account updates for a particular account, in this case the account number can be omitted because it's connected to a TWS session, which is logged into an individual account and not an advisor or multiple account structure. True means to start a subscription. So if you want to start a subscription, you invoke rec account updates with true. If you want to cancel it or stop it, you call rec account updates with false, which is what I'll do in the stop function. So after I call rec account updates, I set the subscription to true for this account, then updates are sent first back to update account value, and that has different information, say like the cash balance, or the margin, required margin for the account, or the net liquidity, and different keys like that. Then after that's data returned, and there will be a separate callback for every key to update account value. Then we'll also receive portfolio information back to the callback function update portfolio. So the callbacks to update portfolio will be one for each position in the account, and you can see the different types of information returned along with the position. We'll have things like the unrealized P&L, which will be the total unrealized P&L since the position was open, the realized P&L, which would be the realized profit and loss for the current day if you've closed out any positions, as well as the account name, the current market value, the average cost used to open the position, and of course, the actual position size. Okay? And then with each callback, it has a time to let you know when that data returned completely. There will be an account download end to let you know that all information has been returned. This function is only called after the first full batch of information is returned, and then after that, you will receive updates in real time, but updated download end won't be called because it won't be a complete batch of information. It will only be those positions or those account values which have changed since the last return of data. And since I'm already logged into TWS here and listening on socket port 7497, I can just run this program and it should connect and then call rec account updates, wait 5 seconds, print out all the results, and then call the stop function. Okay, so I just ran that program and we can take a look at the results here. So you can see there are quite a few different account values and positions returned. So these are the initial notifications return in the error callback to let us know the market data farm connection is okay. And then we'll receive all the different account values in alphabetical order. So starting with things like the account code, which is just the account number, will give us information like, say, accrued cash, dividend information, which is just dividends accrued in the account, the cash balances on the different currencies. So you can see these are the real cash balances shown in different currencies. For instance, so there'd be 22,829 euros, or say, I believe that's 5,367,628 US dollars. Okay, and then we'll receive other information, including margin information, leverage in the account, realized P&L for the account. And then after all the account keys are returned, next we receive the portfolio information. So these are the current positions in the account. So you can see, for instance, there's a position Alcoa or AA, a position of 100, which has a current market value of 3,489, had an average cost of being established of 37.15. The total unrealized P&L is negative 226. and the realized P&L is 0, meaning no positions have been closed today. And then we receive a separate callback for every position in the account with that information as well as the time as when that information is current. If we were just to leave this program running and then to make a trade in TWS, if a position was changed, then we'd immediately receive that callback to let us know there's a change in position. But it would only be for that particular instrument and wouldn't be for any other instrument. Okay, and then finally here, at the end of the first complete batch of information, we receive the count download end, just let us know that all information has been returned. Okay, so that's our lesson for today on receiving option chain data, portfolio data, and account information. In the next lesson, we'll explore a simple case study to show how more complicated orders, such as pair trades, can be placed from the TWS API.